Okay, so here is a much more finished design. Zoom in here a little bit. I have almost all of the hardware solutions put in. All the hinge pins, cotter pins, all these oil impregnated bronze bushings. Have pretty much every hinge point. Not a lot of custom parts to it, just a couple. The bell crank, again, have to be custom. I switched to a 45-degree bent design instead of the 90-degree that you guys saw before for movement and mounting of all of this. Both of the blocks here, the mounting flanges for these two ball nuts, are also going to have to be custom made. I chose these kind instead of the flanged because the flanged are much bigger and much more expensive. These actually thread into the openings. It's a 15/16, which is kind of an uncommon thread size. Again, the pitch housing, this can be basically drilled out of a piece of 2-inch round stock, and the arm will also have to be just a cheap piece of steel cut and welded in. The round stock, I can only find it in aluminum, again, more or less because it's inexpensive. No other reasoning behind it. Not a lot of stress at this point. The connecting link, just 2 rod ends, piece of tubing, threaded to accept it, couple of jam nuts so it's adjustable to the appropriate length. The only difficulty I had with the whole thing is the range of motion of the pitch. The lower rod end doesn't move very much in or around the ball portion, but the ball here only has 27 degrees of motion. That's just the limit of the rod end, and that's not even the appropriate rod end. That's just what I drew in to make it all move. Again, 1-inch piping, 1.5-inch square stock, 1.25-inch hollow opening. This would all be one piece that I just added in to have a good mounting surface for this motor. These are just mock-ups of the Maxon motors, have a motor constant of 0.056 Newton meters per amp. This bracket probably should have a couple more feet on it, but they're not very expensive. All of the parts together right now, except for a couple more pieces of hardware, just under 1,100 bucks. Might be a couple more things to throw in. I still have to finalize the design of the torsion bar that's supposed to go in the middle here, get that all modeled out in ANSYS. Again, that won't be very expensive to make. It's just some bushings, some epoxy, and some very thin sheet metal cut into strips. Overall though, I put a much longer airfoil on. This is about 15 inches long with a cord of 10 inches. So you can see that you get quite a lot of plunging motion out of it. That's through the frame. But pitch motion, we're limited to 27 degrees, and there's actually no interference between the ball screw and the connecting link at any point in the range of motion. None whatsoever. We got about a little over a 1/4 inch of clearance between the two. I don't know why that ball nut is turning. It shouldn't be. But there it is. Still should put in probably an LVDT connected to the bell crank, just not sure where to attach the other end to. Strain gauge on the torsion bar, and maybe another LVDT to do the plunging angle. Apart from that, pretty well complete.